Well, hello guys, here Mr. G, and we are going to continue with the lessons related to vectors. This is for the grade 11s, okay, mostly. Now, it is applicable for grade 10s and it's applicable for grade 12. Grade 12 will be using vectors all the time throughout the year, and the grade 10s later at the end of the year they're going to speak about vectors, but you already can know and can watch the videos as well, okay? So last time we did just a summary of the grade 10 knowledge that you have from vectors, okay? And we end that lesson by practicing and recalling how to add collinear vectors using the method tail to head or head to tail, and using the algebraically method. Now this time we're going to specifically of what is in grade 11, and in grade 11 we're going to start introducing the Cartesian plane that you do in mathematics, but this time we're going to be drawing vectors on a Cartesian plane. Alright, so this is the Cartesian plane that you do it in mathematics. Is exactly the same. The only thing that the minus here means direction. So all these negative numbers on this side here means that this is the negative direction as well as this one there, but the rest is exactly the same. You can represent vectors here, but now the direction will be given in terms of the axis. So if the vectors are pointing in this direction, we say to the positive x-axis. So that is how we are going to be given directions there. Or here we say to the positive y-axis. Alright, so that is in terms of direction and the Cartesian plane, but you know how does the Cartesian plane work. Now here we can add vectors using the same method as you did in grade 10, the one we practiced last time. For instance, let's say we have a vector f1 which is, let's say, 3 Newton to the right, or in this case to the positive x-axis. So let's say we have these vectors on the Cartesian plane. Now I didn't write the direction because the direction is given by the head of the vector. So we have first one, which is 3 Newton. Each block will represent 1 centimeter, and therefore it's going to be 1 Newton here. Let's write the scale. Let's do the things correct, and let's say 1 centimeter is equal to 1 Newton, which is 1 block. Okay, so that is important here. Right, now note here in the X you can represent it in either centimeters or you can represent it in newtons. So look at the question always, how do they represent the axis, if it's in newtons or in newtons or in centimeters, and therefore you must always look for the scale. Okay, so now what we're going to do, we are going to add these vectors algebraically right on the axis. So we're going to continue doing algebraically, graphically right on the axis using the same method as we did before. So we're going to take one vector and we are going to place that vector right on the axis. So for instance, I'm going to place it right there, a little bit on top. So there is f1. Now right on the head of the first vector you are going to represent the second vector. In this case we're going to represent the second force starting from the head of the first vector you draw. So I'm going to do it right there. Okay, and then right on the head of the second vector you are going to place the tail of the third vector you draw, and here is the addition. So that is how to add. Where is the resultant going to be? First of all, let's try to get this one there, except the 3 is not going there anymore. It's difficult to work with this one sometimes. This is -3. So where is the resultant going to be? Well, from the tail of the first vector, which in this case is right the origin, to the head of the last vector, which in this case is -4. Remember, there must be a -4. So the resultant vector is the vector that is going from the tail of the first vector to the head of the last vector. That one there is the resultant force, which is that one there. And because it's on the y-axis, sorry, on the x-axis, we're going to call it resultant R. So this vector is the resultant force. Let's do it a little bit down there. We are going to call that force FR, but in x, because we are working with the x-axis. So that is the resultant force in the x-axis. So I hope you understand. Nothing changes. It's the same way as we did in the gray tens, but now is on the axis. So the direction will be to the negative x-axis if you want to give a direction, but in this case you can see the head there, so you don't have to write the direction. Okay, now in the y-axis will happen exactly the same. For instance, we have a force 4 which is pointing up the y-axis or positive y-axis, and we want to calculate the resultant of F4 and F5. So we place F4 at the origin as it is here, which is 5 Newton. Right on the tail of that one, we are going to place on the head of that one, we're going to place the tail of the other vector, which in this case is there. And the resultant force is going to be from the tail of the first one to the head of the last one, which in this case is going to be from the origin to that head there. And this will be like this. It's going from the tail, from the tail of the first one to the head of the last one, and this vector will be the resultant vector in the y-axis. You can see there from the tail of the first one to the head of the last one. This one here is what we call the resultant force, in this case the resultant force in the y-axis. So now we have two resultants. If we redraw this axis quickly with only the resultant, so if we take all the other vectors out and we leave only the resultant, this is what we have. We're always going to have two resultants, one in x and one in y. Okay, so this is what we're going to do. We have these two resultants and we are going to add those two vectors. Okay, now those two vectors are not pointing, or they are not collinear vectors, they are a right angle. So how we are going to do it? We're going to do it exactly the same way. We're going to place the tail of one vector right on the head of the other vector. For example, we're going to take this vector here, and we are going to place it right on the head of the other vector. Obvious, the head must be part of that. The head must be part of that vector, is part of the vector, and this is the vector or the resultant force in the y-axis. Now where is the resultant going to be? And this, guys, is how we do it. We take a vector that is going from the tail of the first vector to the head of the last vector, and this is what we call the resultant force. This is the resultant force. Okay, now there is another method to do it, which is called tail to tail. Now let's see if we can do the tail to tail method. Now, how do we do the tail to tail method? Well, we're going to draw parallel lines to each of the vectors of the resultants of the x and the y-axis, and here are the parallel lines. Okay, so note this one must be moved a little bit up. There we go. So let's just fix that one real fast. There we go. So we draw parallel lines to each of the vectors, and then the resultant will be from the tail of the two vectors to the head of both vectors. And if you notice, this one here is the same as we did before. This one is the final resultant force, that one there, which we later on going to learn how to get the values here. Alright, so we're going to learn how to get the values here, but for now you know how to graphically represent the resultant vector, the y resultant, the x resultant, as well the final resultant. And this is all for this lesson, guys. Next time we're going to now learn how to do the actual calculation, either algebraically, or how we are going to get the values after we represent it graphically like it is here. So I hope it helped. Thank you for watching. Remember, you can suggest and you can ask questions. If you have any problem with a specific question, you can ask and I'll do my best to do it for you. But thank you. We are going to next time learn how to calculate the magnitude of that resultant using algebraically calculation, as well as using the graphical representation, which we just did here. But thank you for watching. I'll see you next time. Mr. G here.